Okay, welcome to day two for Cinder. Just a couple of things. Happy hour is later today at 1600 in Meetpad, so there's a link in the Etherpad that you can find for that. And we'll do the team picture then, so make sure you show up if you'd like your face to show up in the team picture. Oh, please sign in on the Etherpad. I see most people are doing that, so that's great. And just the foundation's been asking us to keep track of attendance. We had 39 people connect to Blue Jeans yesterday, and that's after I accounted for duplicates. So we had, pretty good attendance. All right, that's basically it. Chuck, we've just been talking a little bit about some second thoughts about the RBAC and whether it relates to lower level stuff at the drivers. But I was just wondering if anyone has some second thoughts about yesterday, anything they want to bring up before we get started with today's session. Right, I started looking at the notes that Arcadia had left for the interop working group. I'm going to ask him to just come to our. It just so happens that our meeting next week is the last one of the month, so it'll be in video. So I'm going to just ask him to come, and hopefully we can just, because I started to try to answer some of the questions, and I think we need somebody there to mainly sort through the issues about microversioning and whether, what exactly we're trying to accomplish by introducing new capabilities. So we'll just discuss it with them. I mean, my main concern is that, it's for interoperability. So the idea is to identify the minimal set of volume operations that should be available in every OpenStack cloud. And in one sense, all right, that's v30, but in another sense, you'd want to say, well, if we're, at this point, we figure everybody's running, well, this is not true. Well, we figure everybody's running at least Queens, right? So we should at least be up to that microversion and just say, we're using these things. Or some of these features are, I don't know how to do it, right? Because people ask us to do features because they want to use them. And so we want them to be used. And so, of course, we want them to be exposed in all clouds that can do it. On the other hand, so I personally have a difficult time saying these particular APIs are necessary and should be exposed, but these other ones are sort of optional. Because the clear line to do that is at 3.0. But then that makes it, anyway. So that's why, so what am I saying? I'm just saying, so anyway, that's my second thought about yesterday. So we'll talk about that with the working group and see what they're thinking, because maybe they have a better way to explain what it is they're trying to accomplish that will help us out here. Anybody else? All right, cool. Well, today we're kicking off with the, oh, I'm sorry, somebody.
Yeah, Brian, I just had like a small concern. Like we have certain APIs that are admin only that we thought will be system admin only, like reset state of a resource, anything. So what's the thinking about that? Like, are we going to discuss that later, everything, or?
So those are kind of a weird thing. I think the idea is that admin, so the interop working group doesn't, so admin only APIs are not included in required capabilities, mainly because you're probably going to have to expose them if you're going to actually administer your cloud to yourselves, right? So we're really only interested in terms of end users of OpenStack clouds. We want to make it the case that you can go from cloud to cloud and your scripts should work and you should be able to find your way around easily. And the kind of right, if you are used to creating volume snapshots in cloud A, you should be able to do it in cloud B. And then maybe
sorry,
I'm sorry.
Sorry, I was referring to the secure RBAC thing, not the interop.
Oh, that's easier. Since it's not a system resource, it's a per project operation. I mean, it happens on a per project on a project resource, it is not a system operation, system scoped operation. They change the status of a volume, for example. That's on a volume. The volume is a project resource, so it is not system scoped. That's what I think when Dan said yesterday,
Yeah.
the clarification of scope is not for the user that is being provided. It's for resources. So if you're talking about a system scope, it cannot access resources. It can only access system scope things that are mainly the things that don't have a project and a user. Volume types don't have project and user. What else don't have project and users? Services, no project and user. Cluster resources, no project and user. That's the kind of operation that system scope does.
Yeah, but
The
Yeah,
rest,
so the problem I'm seeing here is that, right, we have the 3 default roles that Keystone provides, and we want to be able to use all of those with respect to users, or at least that's the way it was introduced, was that normal end users can have the reader or the member or the admin role, right? But when you have something like reset the state of a volume, right, this is no longer a system scoped operation given the discussion we had yesterday, because we're trying to affect something that's inside a project. But we don't want to give, right, an end user the ability to do that in any
or a
project.
project admin.
Not even a project. Well, see, if we do allow a project admin to do it, right, then we can no longer apply the admin role to ordinary end users.
Yeah, that's what my point is. So are we going to give that to a domain admin or something? Like we can't allow
Well, no,
project
see,
admin to reset it.
even the domain admin, right? It's my understanding. What we discussed yesterday was that you would be, if you're higher up in the hierarchy in a domain, you can get a project scope token for that particular project that you're working in, and then you will have particular roles. But if we say Cinder's going to recognize the admin role to allow you to reset state of a volume, then we can no longer have the admin role be used to like do the thing we want to do with the default volume type, right? Because we're back to the same point where somebody who's an admin can do all the actions. So I think maybe, so I don't even know how to, right? So I think we're either going to have to say we can only have project members as end users for now, or they're going to have to introduce like another role, like super user, and then operators will have to give the super user role only to people who they actually want to do, right, these kind of administrative tasks inside a project, but that we don't want members of a project to do. Or we have something else that's in between member and add. Do you see what I'm going at? So, because we're back to the same thing. Once you've got the admin role, you can do a whole range of actions, and we don't want people to do that, right? And then the idea was that you'd have readers only do read-only stuff, members do most of the stuff, and then admins do a little bit more than members as far as stuff that only affects the project.
but Ryan, maybe I'm missing something. I don't really see much of a problem. If we forget how Cinder has things implemented and we just look at the database structure and the roles that we're discussing, a user admin would be somebody that can do the set Cinder, the set state of a volume, but only if the project and user matches, right?
Right, but I guess my thing was the
In
idea
a
we had
project admin, in a project admin would be for all the users within the set project.
right. Well, the
Because we have
project,
two fields, project and user.
right, but All right, we're gonna have to probably talk about this another time so that we can, yeah, so that it's complicated. Um, I'm, anyway, okay. I'll follow up with Lance to see if maybe we can get Lance to come to our next meeting also to explain, because after a week, I'm sure everybody else has questions like this too. All right, I'll try to write that one down so I can remember to
We can
ask.
probably create an Etherpad and we can all a bit of
Yeah, okay,
so that Lance doesn't come call to whatever we want to ask him.
okay.
And,
All right, I'll get that together. Thanks, Rajat. Okay, anybody else? Please ask something easier. Okay. All right. Thanks. So we got a big discussion today. What's next for NVMe with OS Brick? And Simon's going to lead us through that. So I'm going to shut up. And Simon, do you want to share your screen or anything? I think you can do all
Yeah, I'm going to try and share my screen now.
that. Okay. All right.
Which one? Huh. Okay, it doesn't sort of let me know which one I'm going to. I love this. I've never used sharing screens on this before, and I've got multiple screens, so I don't know which one I'm going to end up sharing. Here we go. Now things come up. Okay. Tell me you can see that.
Yes.
Good, good. Okay, good. So this is not going to take an hour, so I'm okay that everyone was chatting before. But this is more of an introduction, informational session, just to let people know what we're doing. Obviously, we've had a number of OS Brick connectors in the past, iSCSI, Fiber Channel. Now we're talking about NVMe. That is the next big thing that we've got coming down the pipe. A lot of vendors are starting to get interested in it. It's been around for a little while, but we're wanting to see what we're going to do next. And so what we've done is we've set up a working group. The working group currently has people involved who, it's like a birds of a feather more than anything. And I think that's what Chuck calls it. He calls it a birds of a feather rather than a working group. And so we've currently got people from Kioxia, Pure, Dell EMC, and Red Hat involved. And I'm sorry if I've missed someone off there who I didn't notice on the list. We're looking for more members all the time. Anyone who has an interest in NVMe, anyone who is working for a vendor that has got NVMe support, is looking at doing an NVMe driver for Cinder, please join, help us out. We're looking for all the info we can get so we can get this right the first time round. In the Etherpad, there is a link to this brain dump document, which I created some time ago. There's some chat been going on there. The drafts of specs that we're writing are in there as well. So, if you're interested, please go look at that. If you can't access it, it should send a Google share request to me, and I'll just approve you immediately when you request it, presupposing it's in my working day. So I will give you access to that. Don't worry about that. So we're just looking for people to join who have got interest in this. There are two major areas that we're looking at. The first one is fairly critical, supporting NVMe for NVMe multipathing. Okay, the earlier incarnations of NVMe connectors were designed for NVMe drives internally in your compute environments, and they were not using multipath, or maybe they were using RAID. Okay, but they certainly weren't using multipath. And multipath is obviously important, as it is with iSCSI and Fiber Channel when we start moving to NVMe connected backends. So we need to make sure that we've got NVMe covered for multipath. And the second thing we're going to be doing is adding support for NVMe Fiber Channel. Fiber Channel is different when you're talking about NVMe to the current RDMA and Rocky type connections. The connection, the commands we do to start those initiate the connections are different. They've got different parameters. We have to find different information out, like we do between iSCSI and Fiber Channel. There are WWNs for iSCSI, for Fiber Channel NVMe, in the same way as there are for regular Fiber Channel. So we need to get all that information as well. So those are the two main areas we're working on. The first main area we've broken down into two parts. So this is the multipath phase, and we've got the spec in development, the drafts of those, specs are actually in that document, as I mentioned before. 2 phases. The first one is to support native NVMe multipathing, and the second one is to support DM multipathing, because at some point we have to consider the lowest common denominator. DM multipathing is something that probably everyone is going to support, and not everyone is necessarily going to support native NVMe multipathing. It's a little bit more complex and does things in slightly different ways, so we have to be careful about that. Also, DM multipathing is going to be required, we think, as we move more into replication of external NVMe devices. Particularly when we start talking about synchronous replication between 2 backends, we're going to need DM multipathing to support that. Also, there are potentially the NVMe spec isn't particularly tight, and there are opportunities for a single backend to actually create multiple NQNs, which is the NVMe equivalent of an IQN, and so that would require DM multipathing to work. And there's also the possibility, and it gets even more complicated at this point, is where we could put DM multipathing on top of native NVMe multipathing. So these are all complications that we need to think about when we're looking at this spec. The 2 phases are broken down fairly simply. Native NVMe multipathing we want to get in for Yoga, and the DM multipathing support we want to go for the Z cycle. There's a stretch goal to get it into Yoga. There's a possibility we might be able to get some of the low-hanging fruit for DM multipathing into Yoga, but it's really targeting for the Z cycle moving forwards. Obviously, as we do this, we're going to have to do a lot of validation of the code. And the only way we're really going to do that is by using third-party CIs that actually have full-blown NVMe connected backends in that CI system. There are some CIs out there already that are doing testing of the existing NVMe connector. So that's the SPDK and the Kioxia CIs. I'm not going to get into the difference between old mode and new mode because I don't truly understand it. And I'm sure if you ask the question, one of the guys from Kioxia will be able to tell you what the difference is between old mode and new mode. But the SPDK CI is testing the old mode, and Kioxia are now testing the new mode. And they're actually going to be the first people who are going to be starting to test the native multipathing as we write that code and that spec comes to fruition. They're going to be putting that into CI. Pure Storage are currently working on building out a brand new CI environment that's going to support Rocky V2 / RDMA, however you want to call it, and Fiber Channel NVMe. So that will be a good new external platform that we'll be using there to test those new platforms against. And when Pure supports NVMe over TCP, we will also add TCP into that CI environment as well. One of the initial things we have to do, and I'm going to thank Gorka for all of his hard work in this, is we need to get NVMe support for LVM into DevStack so we can at least do some functional testing. And a lot of that work is already in flight. So there are 2 patches out there. The links are there. Can someone grab those? In fact, I'll try and grab those and put those into the Etherpad in shortly, unless someone beats me to it. So Gorka's written a patch for DevStack to put NVMe support for RDMA and for TCP. They're very, very similar. RDMA and TCP both use Ethernet as their transport protocols, and so effectively they're the same, but there are subtle differences. RDMA uses specific NVMe initiators, so things like Mellanox, Connectrix, X5 cards, things like that, whereas TCP, which is a little bit more easier for people to use, that just uses regular Ethernet cards. Okay. Gorka's also working on a patch to support NVMe over Fiber Channel in LVM as well. But what we need is more vendors who have got CI capable backends to build out NVMe capability in their CIs for all of the different protocols. So that's something we would love for people to try and join this working group and help us get those things going. So that's part of the call to action for this group. So anyone who is interested in learning about NVMe, knows anything about NVMe and feels they can contribute, all contributions are gratefully accepted. People to come and review the patch sets that Gorka's already got up, the stuff that Kioxia are going to be working on as well. Please review those patch sets when they come up. We can't get this stuff in unless people who know what they're doing review it, and then the cores can have a confidence that those reviews have been are good, and they will be able to plus to it, hopefully, at that point. If you want access to that document that I mentioned before, that working document, please feel free to request access. Please feel free to add anything in there, add comments, corrections, all completely welcome. More information in that brain dump document, the better moving forwards. And again, final thing, reiterate what I just said in the previous slide. If you're a vendor with an NVMe system, NVMe capable system, I know there are a couple out there who don't have, or we're not aware of them doing Cinder drivers for NVMe. If you're planning on doing it, please build your CI out so that we can test all of these different protocols for NVMe as we move forward. Without those, we're not going to get this stable. We've already had a number of issues with the NVMe connector where we haven't fully tested because we haven't got full test suites. People have been reliant on the person who wrote the patch and a couple of people who vaguely knew what they were talking about reviewing it, and then it's kicked up issues in Nova and things like that, which we've fixed now, but we don't want that to happen again. We'd like to get this as correct as we can the first time round. So that's my spiel. And yeah, I noticed that Gorka's put the links in. Thanks for that, Gorka, into the Etherpad. So yeah, any questions, any comments? Happy to chat about those. We've got a couple of people in the working group on this call, so we can all answer questions. I knew this wasn't going to be an hour long.
So with the new DevStack capabilities that Gorka's introduced, is the idea we'll have where we're going to run that CI job? I guess let me back up for a second. So as one of the people who's been reviewing this code without really understanding the protocols, I've been relying on CI results, and I need to have a better understanding of which ones I can look at. Short of going to what I wound up doing for the the first Kioxia thing was I looked at stuff that looked like maybe they were using it, and then had to go look at the cinder.conf in the CI results to see if they're actually using that connector or not, and it turned out almost nobody was. So that wasn't really efficient. So I guess what I'd like to see is we need some way of identifying which CIs are important for this and which ones to pay attention to. And also, well, I guess I'll shut up and let you answer that.
Well, the first thing to say is that the DevStack support for NVMe is obviously for LVM, so that's software based. So that's going to test a lot of the stuff, and that's all the work Gorka's doing is going to test a lot of that. But it still needs to be validated. You're absolutely right, Brian, on real backends that have got real NVMe connectivity. So we've got Kioxia already that is definitely using an environment, but the Kioxia environment is obviously unique to Kioxia. And then obviously Pure is building out our own environment, which will be just, hopefully we can start using that. But anyone else who wants to drop one, maybe someone's already in the process of building one and they just haven't made it go live yet. That's what we're trying to find out. I know there are a couple of vendors out there who have got back-end arrays that fully support NVMe connectivity to the host. We're just not seeing anything, and I don't know whether they're working on drivers, whether they're not going to bother on drivers. This is what we need to try and find out, because Pure's going to do this, and then Pure can maybe be the first starting point, and if things pass the Pure CI, then it's a fairly good representation that the NVMe part the NVMe part of any patching is correct. But we can't rely just on one CI, and particularly as ours is not going to support TCP initially, because our backend doesn't support TCP initially, it only supports Rocky V2 and Fiber Channel. So we'll more vendors.
Brian, I think we can do what we used to do with Fiber Channel, with multipathing, ISCSI, etc. We used to know, like, kind of have a noise break at different backend that we knew was testing each of the different aspects. For example, we had Pure for Fiber Channel multipathing. Whenever I saw a patch that did that touch that area, I would go and check the results of that specific CI because I knew that was the relevant one. Then we had others for multipathing with iSCSI single target, iSCSI shared targets and everything. So we can probably write something up, kind of this backend. If you're reviewing a noise break patch that touches this connector, look at this one and this one. Yep.
No, that's exactly what I'm asking for, because on the Cinder side, when there's driver changes, it's pretty obvious which CI to look at, right? But on the Brick side, you never know what connectors exactly people are using and which tests are relevant and which aren't. So that would be great. So I think it would probably be good to have this for all the connectors, but at least for this one, if we can get like a small chart or something explaining which ones are testing what, that would be enormously helpful.
That would be useful in the CI name as well. I think that might be an easy way to start. Simply name it. So at least specifically for CIs that run against Brick, in there we could, have a part of the CI name keep the connector name. Yeah. Right. So so in the case of Brick, it's all gonna be non-libvirt attachments. So it's all gonna be host-based attachments. So in this case, all of them will be using a connector. So we could make a standard where each CI that tests Brick and utilizes Brick will name the connector type. So another thing I want to ask here is, so the DevStack support for testing NVMe. So this looks amazing, looks great. So as what I can see, I've started looking at those patches and trying to understand how this is working. Now, the first thing I'm seeing is that this is for LVM, right? So the way does this code path, would it even hit the NVMe connector?
Yeah, I'm glad you asked that, because that was one of my questions, is what exactly does NVMe with LVM mean? Is it just building LVM volumes on top of NVMe devices, or is there something more to that?
Is basically what we currently do, for iSCSI, that we have an LVM on the Cinder volume host, and then on top of it, we use DGT admin or LIO admin tools, and they export those volumes via iSCSI. So they serve as the server, let's call it.
Yep.
And for NVMe, we also have NVMe-T. And right. That's basically that's the same thing. It's a device on the host, which is the LVM device that Cinder has created, and exported via NVMe.
So that answers this question. Now, I'm wondering, we have LVM devices that are exposed via, whether it is iSCSI or in this case, NVMe target. So the target configuration part, how does the target know what to expose? So I assume there should be a driver for it, right?
LVM, because for the LVM driver, you have the driver itself and their target helpers. And it's in the target helpers where you define LIO, DGT admin, NVMe-T, and all those. And by defining them, you load different code. So there is under Cinder-volume-targets, you can see the different targets in there.
Right. So the next question is, this will expose connection information the same way a normal backend driver would? And based on
Yes.
that connection information and the protocol, then the connector, which connector to be used will be decided. Okay.
Exactly.
Okay. That actually answers my questions. That is really good. Okay. Thank you very much.
No problem. The nice thing about NVMe, RDMA, and TCP is that we can do it without any hardware. The problem with NVMe fiber channel is that we cannot just do it with a normal fiber channel card. You need a new one that supports not only FCP, but also NVMe fiber channel, which I don't have, so that's a kind of problem for, let's call it, a normal developer to actually test that code.
Yeah, you need a Gen 6. You need a Gen 6 card. And the problem with Gen 6 cards today is that they are like rocking horse. You can't get them because of COVID. We're causing all sorts of problems for us to try and get some and build out. That's part of the reason our CI system is being delayed, is because we can't get Gen 6 cards.
So we will be able to run in upstream CI with LVM, NVMe, TCP, or RDMA. Doesn't matter, we can do it. But for fiber channel, we won't be able to run it. We will have to relay, for example, pure CI, because we don't have the hardware tested upstream.
Yeah, and that's where the issue lies. Is we can't rely on just our CI. We have to have, and again, ours isn't built yet because we're still missing hardware. So a lot of this stuff is, as we move into that, and that's part of the reason that fiber channel is second priority after NVMe, because that gives us a little bit of window of time to actually maybe get these things built and actually get the hardware so we can do the testing. But anyone who's got Gen 6 cards, build a CI environment.
I think one good step for us is, besides the vendor-specific CIs that Pure is coming up. We got Kioxia, we got SPDK. So obviously this is something that was already mentioned, is this LVM NVMe CI. So as Gorka was mentioning, that could be the first real gate. So that would be an OpenStack internal type of CI that, of course, we have the hardware limitations here that we were talking about fiber channel. So I'm obviously, does not solve the fiber channel question, but this, just since we're talking about CIs, this is going to be very useful even, before, let's say, we hit vendor specific CIs. Basically, we will be able to gate changes, especially to the connector, for example, through the OpenStack's own Zool jobs. I assume that's the right thing to call it.
Okay, so that's where we're at. Hopefully we can get this in for yoga. There's certainly the multipassing stuff anyway. That'll be really, really useful. I know that there is a lot of interest in our customer bases about NVMe. It's becoming the new protocol of choice, certainly for greenfield sites. So, it would be disingenuous of me to say I don't want anyone else to have an NVMe driver and everyone would buy Pure, but that's not going to be the case. So let's try and get this working across the board for as many vendors as we can. All right, and on that, Brian, if no one's answering any more questions, I'm going to hand that back to you.
Okay. All right. So let's talk about. We have a little time, so let's talk about Brick some more, because we got several things going on. So, all right. So one thing we talked about yesterday was the PGP encryption stuff, which is sort of a side thing, so doesn't impact this, but it's got to go into Brick. So, okay. And then we've got the NVMe next steps. So part of that's going to be the CI, so the patches that are above. And then I just want to be clear on what we're going for so we can progress. So we want to go for multipathing is the key.
Native multipathing is the bare minimum we want to get in.
Yeah.
And then the stretch was the what's called DM multipathing.
DM.
Device mapper, the one we currently use for ASCSI and fiber
The
channel.
one we use for everything else. NVMe has to be awkward and have its own special version.
Okay. Okay. Now the other thing we have outstanding from Xena for Brick was the what was the name of the healing agent? Well, I'll call it the healing agent.
Connection agent. Well, that's how we called it, at least. NVMe
I'm sorry,
connection agent. A connection agent.
Okay.
Yes.
So that's what was the stat? Okay, so that was it ran up against reviewer bandwidth problems just before the deadline for Xena. So those patches are still there. So we should probably. So I'm assuming it's still a priority for Kioxia to get this completed.
Yeah. So there's a couple things I would like to say about this. So
Okay, good.
So okay. So one thing is, I don't. I rather just be straight about this, and the agent can live. This connection agent can be a Python code and live inside of OS Brick, but it doesn't have to. So it could be just any kind of process, basically a daemon, such as, for example, multipath D or something like that, something that basically is running in the background and monitoring the whatever kind of connection you got going, and is basically doing self-healing, etc. So this is the first point. So this is definitely necessary. So especially for Kioxia's mode of operation with replication, especially this client-side replication, which is a cool new mode of operation that we haven't really seen around, and it has its trade-offs, but there's some cool benefits to it too. And it's basically utilizing RAID on the host in order to do the replication part. So it basically assumes the high bandwidth that you get with NVMe, and it utilizes that to basically remove stress from the backend and taking care of all of the replication, basically. Now, so we tried to get that in. He ran into reviewer bandwidth issues, and it didn't get in. However, there's a few patches that basically I snuck those patches in. I snuck a bunch of stuff into this connection agent. Okay, so. Otherwise it would have been a whole bunch of patches together with one massive patch plus a bunch of other small patches, and they're all kind of like interrelated with each other. And I that's basically the way I did it is I just put it all into one massive patch, which obviously made it a little bit more difficult to review, etc. So I can understand that. But basically, once I saw that this is running into this bandwidth issues, then we broke out the most kind of critical fixes for the connector that Kioxia has basically came up with over the Wallaby cycle, towards the end of it, let's say. So that's also in the middle of Xena, basically. But during the Xena time, the most of the work was just generating this connection agent. But since it didn't get in, we got a few little patches. Now the problem here is this: we either put in this massive patch that includes those little patches fixes, or we go step by step. So I already put in those. I already kind of factored out a few of the most important ones of these little patches. So there is some kind of refactoring work that was needed even for the connection agent itself to work. However, that I did not put that into those little patches because that's part of what makes the patch massive. So I just included things like, for example, even allowing support for kernels that have multipathing enabled. So there is one patch there now that actually the Kioxia CI, it has to cherry pick it now. And that's why it has a little bit of issues running against OS Brick until this patch merges, because it relies on this patch. Since now we basically, it's running on Ubuntu 20, which is basically the, let's say, standard tested environment for DevStack, at least as far as I saw. I'm sure it's also, or you can also run it on, the new CentOS, so I guess it's Stream now. I'm not even sure, but yeah. Basically, the issue there is that we need to get this in one way or another. So if we get in, for example, this multipath kernel support independently, then there will be a conflict with the agent, right? So there's kind of one question how to go about this. I have no problem actually like breaking stuff down, and we don't have to merge this massive patch, etc. But the question is, how do we go about this? Do we want to, go step by step here and merge the little patches one by one, and then worry about the big agent as it comes? Or do we want to go like, steamroll through and just review this whole agent and, basically get everything in kind of together?
So when you talk about the multipath kernel, are you talking to the device mapper, the NVMe?
So I'm not even talking about any multipath implementation. What I'm saying is that the connector has two modes of operation. The new mode of operation, which is, I believe we are planning to also use it for multipathing, both for native and for DM. So I think we're basically going to continue with the new API, basically, of the connector. So this new API implementation currently in the upstream has an issue with kernels that are compiled with multipath enabled. So there's a way to check if the multipath is enabled. And what happens is that
multipath is native multipath. Is NVMe
right.
Okay,
yes,
that was my
yes.
question.
Okay, I see what you mean. Okay, yeah. So, but it's not using. So there is no multipath actually being used right now. So the code does not actually allow multipath to be used, even though that's actually pretty small work. So I'm working on the spec for this now, as you guys know. And the first patch also it's probably gonna be pretty simple, especially if we just keep it to the native multipath besides the DM multipath. Although I'm touching on both the DM, of course, and the native in the spec that's coming up. But what I just want to say is...
I think I get it. Let me see if I finally got it. I'm a little slow today. So since the Ubuntu version is newer now, suddenly for DevStack, the one you're using, it comes with multipathing enabled by default. The NVMe multipathing enabled, so that creates a problem for the connector right now. So you have a patch that checks if the system has it enabled and works around to make it work.
Well, kind of like that. So, doing the checking part, we should do that too. That's something that we were discussing also before, which is the implementation details for what we're going to do with actually using multipathing. However, this patch, what it does is it basically, now what I wanted to describe is that when the multipathing is enabled, then NVMe devices are actually exposed a little bit differently. The device name has another letter and a number. Okay, so it makes things more difficult. So you can either check.
Preconditioning may not have an impact.
You can either check for that.
Like that. Are you able to see my terminal?
Yes.
Hey, Joel, I think you got to hit mute. Joel,
the left
Joel, you
is
got to
local
hit mute,
drive,
please.
which is not completely preconditioned.
Ryan, probably you can mute.
NVMe over fabric volume.
I'm trying to
the
find
moderator, right?
Yeah. I just muted everybody. That wasn't good. All right, let me try.
I show you NVMe
I should be able to.
Okay.
I'm going to call him.
Yeah, can you guys hear me?
Okay.
Yeah.
Yep.
Yeah, sorry about that.
Okay. So basically, what I was describing the different, just because your kernel is compiled with NVMe enabled, without you using multipath enabled, without you even using any multipathing, the devices are going to look different. And rather than having to check for it, then there's a way that is basically transparent and does it correctly for both cases. So this is that's what the patch does. I'll pull up this patch. You can see it's actually very simple.
Yeah, I now remember the difference in the devices. Yes. So I think that is kind of a critical patch from the NVMe
Yes.
perspective.
Yeah. Yes.
And
Yes.
for both connectors, the old and the new one, this is a
It's for
problem
everything.
because
For
right,
NVMe in general.
NVMe. Yep.
Yeah.
Okay,
So
so
this
I
this
think
patch is
that
just the
patch
way
is
to
high
go.
priority.
Yeah, I think so too. I'm trying to share it here. I don't really see. You know what? I'll just put it in the
Yeah, please.
Etherpad. So okay, so you guys go on. I'm just I'm typing it in.
So while you're typing that in, I just want to bring something else up about Brick and bandwidth for reviewers. There's still one particular iSCSI issue that needs to be backported, and we still haven't even got it into Xena yet, and we want to get it all the way to Asuri before Asuri goes EM. So we've had one, Jay's already +2'd it. We need some more cores to look at it, some stable cores to look at getting this thing backported as soon as we can. We've got customer issues because of it.
What was that?
I will put that into. Oh damn! All right. Who's going to beat me to it? I know they are. I just can't get my things to work properly. Oh wow! Seriously? I have got a new laptop and the mouse pad is so flaky. Doesn't do anything I want anymore. There we go. Okay.
I hope it's not a Lenovo.
It is.
No.
It's a new X1 Yoga.
And the mouse pad is flaky?
Yeah, it's so sensitive. It's ridiculous. I've turned sensitivity all the way down, and it's really sensitive.
Oh, I was going to say if I was going to ask if you turned it down, but okay.
Yeah, I've turned it down, and it's still ultra sensitive. It's like just floating over the air, and it'll detect it, and it's weird.
Wow.
Yeah, so that's the backport patch in there as well. So yeah, if we can get some cores to review that, because once we've got Xena in,
Yep.
then we're going to go back to Wallaby and then to Asuri, and I need people to be on this one so we can get.
I review it.
Yeah,
because I reviewed the original one, so yeah, it's an easy review.
Alexa, show front door.
My Alexa doesn't know front door, so she can't do that.
Oh, I guess my mute was delayed.
It was.
Well, that's weird because there was motion. There's nobody out there. Oh.
Ooh. Spooky.
Halloween.
Yeah. Alexa, stop.
Thank you.
Okay, so do we do we come to a conclusion about the connection agent?
Well, for
That's a
now,
good
he has displayed a couple of patches, and at least one of them is critical. So, or at least I consider it critical. So I think it's good that he has moved it out because it's probably easier to review it and test it. So for that one, at least, I will be reviewing and experiment and everything. And the other ones, I haven't looked at them, so I'm not entirely sure if it's okay to have them outside or to include it.
Okay.
The refactoring, I think it's fine to include it in the big patch, because if it's refactoring needed for the patch, then it makes sense that it's there. but I don't mind if it's altering. I think we just have to kind of make the effort. Basically, this is a self-note. Make the effort
Yeah,
to
no,
review this.
that's well, not just for you, right? Because it takes more than one to get things through. Um, so we need to, I guess what I'd like to see is we should merge the agent early. So I guess it's good that these fixes that are associated are critical because that gives us some motivation to get the small ones done. But the agent shouldn't really affect much, shouldn't affect the connector. So we should be able to get that reviewed and completed. So I'd like to just say we should make an effort to get it done by milestone 1 for sure.
Yeah.
Um,
Yeah,
so
one good thing about the agent is it doesn't get hit by any code pass at all. So it's just its own standalone thing. So no code actually hits the agent. Connector, no nothing in OS Brick. So it's meant to just be launched by itself. It's a console script, and all it does, it does share some code that the connector is using too. So that's the reason for the refactor. So they both are using common code, but there is no code that actually uses the agent. So that's I think a good thing about it. Why we shouldn't really be worried about merging it, because I mean, at least in theory, it's not going to affect anything unless you launch it, and that will be a separate process. It will be different from any other service that's using OS Brick.
has anyone other than me taken a look at the connection connector agent?
I'm gonna dump the link for it in the Etherpad for the patch.
Yeah, I think it's the one at line 253. I think I just put it there. That's the right patch, right?
253. Okay. I'm looking. I think it is. Yes.
Okay. So the only thing I'd ask you, so right, we don't have any CI to actually run the thing or launch it. So even though it doesn't affect anything, it would be good to know that you can, launch it. So
Yeah.
if you could attach some logs or something to just show that, how you're deploying the thing, and that it doesn't break stuff, that would be fantastic. But otherwise, I
Right.
think it was looking pretty good. I mean, from what I remember, but it's, I looked at it for milestone 3 and then stopped.
Yeah. So I will. I think I opened some kind of Etherpad for it at one point, and I think I even lost the link for it.
Okay.
That was your
There may
suggestion,
even be
by
a
the
link
way.
on there.
Yeah, okay, nice. Anyway, yeah, I will make an effort. So the thing is, this patch, I haven't actually touched this patch in a while. One thing about it, and it's I think it's okay that we didn't rush head first merging it anyway, because there's still tested needed for this thing. So for example, in-house Kioxia Kumuskel was testing the stable branch of this, in a sense, which is the way we did it in Wallaby, which does not have its own console script, and instead it actually gets initiated and runs in a separate thread by the connector. So which has a bunch of issues for being done this way, but that's what we have well tested, and this is something that we could probably be testing more. So what you're saying about needing, maybe the CI does not hit it, but this is a very good point, because at the very least, I'm going to provide documentation for how to launch the agent, and maybe throw some logs of it. But
Okay.
we're going to have to think of a way to test it. Okay, so whether it's adding some Tempest tests, we're going to have to figure that part out too.
Okay. Yeah, I guess we could do a Zool job that launches it. I'm not sure. All right, we'll have to think about that. But yeah, I mean,
So The Kioxia CI, we could definitely add something to the Kioxia CI that will do it, right? So launching it is just one thing, right? So we can just launch it and see that nothing else breaks and that the normal Tempest tests don't break, right? So that's already okay. Let's start there. You know what? Let's not go too deep and actually. Okay, you know what? Let's just agree to do it this way. We'll just launch it in our CI. It's going to be a very easy change, you know, especially once it's a merge and etc. Don't have to cherry pick it, etc. We'll just launch it. So every CI run by Kioxia will launch the agent and then do the normal CI run, the normal volume test, etc. And if nothing, this will basically see that the agent is not breaking anything. It's not going to test the agent actually doing any healing, but it will at least, show that we're passing all tests while the agent is running, which is
No, and that would,
actually,
yeah, and that'll actually be good because it also, you have to make sure that the configuration is working correctly, right? So it'll help with the documentation stuff also, I think.
okay.
So it'll just be that the agent is packaged in Brick, actually deploys and is finding the config options from where you expect it to. And then that would be great. And then I think once we've got that, so yeah, so you can do it in the Kioxia CI and just link to the the logs that show what's happening to help out the reviewers, and I think that'll be good. And then the other thing I wanted to say was just, please stay on top of us on this one. I think you've earned the right to bug us at weekly meetings about what the status is. So as soon as you got that available, let us know, and so that we get into this. So I'd like to see this merged by M1. And I see it's a little bit up to you, but it's mostly up to us to get it reviewed. Okay. Any questions or comments? All right. So a lot of Brick action for yoga. So that's good. It's been kind of languishing a little bit. Give Brick some love. Okay. All right. I'm going to stop the so Blue Jeans has a 2-hour limit on recordings, so I'm going to stop it and then restart it for the discussion of clarifying the volume driver, which may be it may be of interest to have that recorded or not, but we can decide later. All right, so anyways, I'm going to stop the recording now. So thanks, Simon, for getting this going, and thanks, Zohar, for explaining what's going on with the agent and the Kioxia stuff, and thanks, Gorka, for getting the work done on the LVM so that we can test this connector better. So cool. I will now stop.